this video, we present to all of you about EI function solution. What is EI function solution? In the year of 1967, Matthew and Russell had proposed a solution to the diffusivity equations. It is based on these following assumptions. The first assumption is the reservoir is infinite in size. The second assumption is the well is producing at a constant flow rate. The third assumption is no flow across the outer boundary, for example, at the radius. The fourth assumption is the reservoir is at a uniform pressure, Pi, also known as initial pressure, when production begins. The fifth assumption is the well with a variable radius of Rw is centered in a cylindrical reservoir of radius Re. This well can be summarized based on this figure. The inner circle represents the Rw, which is wellbore radius, while the outer circle represents the Re, which is external radius, which is from the the center circle until the outer circle.
So, based on the several assumptions from the previous slides, they came up with a solution which is expressed by this equation, which is PRT. In short, they can calculate the pressure at radius and at a certain time, which means they can calculate the pressure at any point or at any time in the reservoir. And this equation consists of several parameters, which includes the time, which is calculated in hours, the flow rate of the oil, which is calculated in Stockton barrels per day, the permeability, which is calculated in millidarcy, and the most important of all is the EI function, which is expressed by this equation. As you can see, it is a little bit complicated with an integration and a series to be solved. And so we usually approximate the values of EI function based on several conditions. The conditions are: the first condition for approximation are, the first is x lesser than 0.01. Then the EI function is approximated by using this formula, and the value of x is calculated by using this formula. And the second condition is when the value of the x is between 0.01 to 3.0. And in this case, the EI function is approximated by using this formula. As you can see, these A1, A2, and A3 coefficients which have fixed values of their own. So in short, once you calculated your x and the value of your x is between 0.01 to 3.0, you just have to plug in the values of the coefficients of a and x, and you can get the approximated value of EI, and in turn plug it into the previous equation in order to get the pressure at a certain radius and certain time in the reservoir. The third condition simplifies things, which is when x is bigger than 10.9, since the EI function will be approximated to 0, which further simplify your calculations. I believe things will be much more clearer with the aid of an example. So here it is.
Bismillahirrahmanirrahim. So let's have an example. So this is the question. An oil well is producing at Q equal to 300 STB per day under unsteady state flow condition. The reservoir has the following rod and fluid properties. So these are the information given. So the first question is calculate pressure at radi of 0.25, 5, 10, 50, 100, 500, 1000, 1500, 2000 and 2500. And the second one is a plot the results as pressure versus radius. So what is the keyword? The keyword is unsteady state flow condition. So there's four assumptions. The first one is infinite acting reservoir. The second one is Q is producing at constant rate. The third one is PR uniform when Q begins. And the last one is no flow across outer boundary. So how to calculate the pressure at the specific radius? So we have to find the EI first. So if you want to find the EI, we can just enter the information into the equation of X, which is equal to 948 times with the porosity, the viscosity, the compressibility, radius, and over the permeability times time. There's three cases. If X is less than 0.01, then we will have the equation using ln 1.781x. If we have the value of x is 0.01 until 10.9, then we can see the EI value in the table. But if the x value is greater than 10.9, so the EI x value will be 0. So by using the equation of the pressure, so we can find the pressure at the specific radius and time by just entering the information into the equation. Then we construct a table for a complete tabulated data. So for example, this one is at t equal to 12 hours. So we have all the pressure at t equal to 12 hours and the specific radius, the respective radius given by the question. So after that, we based on the table, we plot a graph of pressure versus radius. So that's all from us. Thank you.